Welcome to section 4.7. We're going to be talking about the inverse trigonometry functions. Now, does sine or cosine have an inverse? Now, inverse is when we switch those inputs and outputs. So now, for sine of x, our domain for sine is all real numbers. It goes from negative infinity to positive infinity. So we think about the graph of sine. Let's put our max at 1 and our min at -1, because we'll just graph sine of x, the amplitude's 1. So we've got our pi over 2, our pi, 3 pi over 2, and 2 pi. Now if we go backwards, we're at negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. So we're going 0, max, 0, min, 0. We can also go -1, 0, max, 0. So if we draw our graph for the sine of x, we've seen this a bunch. There's what sine of x looks like. Now, to determine if it has an inverse, we use the horizontal line test. Now, if we draw a horizontal line, it's going to intersect that graph at more than one spot. So if we look at the entire graph of sine of x, it doesn't have an inverse. So in order for us to look at the inverse of sine, we need to restrict our domain. We're going to only look at sine between negative pi over 2 and positive pi over 2. We're going to look just at that portion of our sine curve. We restrict it from negative pi over 2 to positive pi over 2. That's our restriction so that we would have it. So we'd only be looking at We'd only be looking at, I can't draw, this. We'd only be looking at that part of the graph. So now if we had a horizontal line test, it would pass that. It would be 1 to 1. Now the reason we want to restrict it to that as opposed to maybe from 0 to pi is that if we went from 0 to pi, it wouldn't be, the inverse wouldn't be a function either. It would fail the horizontal line test. And we went from positive pi over 2 to negative, or to 3 pi over 2, it would just be decreasing. So what we're doing is we're keeping it as y equals the sine of x between negative pi over 2 because it's increasing. It keeps the values of it. We see the full range. The full range of outputs. It's going from -1 to +1. And also it's 1 to 1 in that domain. It has an inverse. So that's the reason why we're doing that. Now the definition of the inverse sine function. Y equals the arc sine. Arc sine, you'll also see it written as the sine inverse. It's another way to say the same exact thing. So you can read that the inverse, y equals arc sine of x, if and only if sine of y equals x, where x is from -1 to 1 and y is from negative pi over 2 to positive pi over 2. Remember, for inverse, we're switching the inputs and outputs. We're switching the inputs and outputs. Now, we can use this. When we talk about evaluating the inverse sine, we're restricting ourselves from quadrant 1 and quadrant 4. We're going to pick quadrant 1 if it's a positive, quadrant 4 if it's a negative. Now, keep in mind, we have our pi over 6. We're at √3 over 2, 1/2. Pi over 4, we're at √2 over 2, √2 over 2. And pi over 3, we're at 1/2, √3 over 2. We also have this point here, which is at 1, 0. Now, our sine value is our y coordinates. So we're looking at the y coordinates here. That's what we're going to be concerning ourselves with. Now, the arc sine or inverse sine of negative 1/2, as soon as I see it's in negative 1/2, I know we're in quadrant 4. I know we're in quadrant 4. So now I just need to see, when is my sine going to be 1/2? I'm looking at this column over here. Sine is going to be 1/2 at pi over 6. And now just to get us into quadrant 4, all we have to do is just put negative pi over 6. That's the same as 11 pi over 6, but it's just a lot easier to work with. So negative pi over 6 is good for us. It's going to put us right into quadrant 4. The sine inverse, remember that's also arc sine, of root 3 over 2. It's positive, so we're in quadrant 1. Once again, you're looking at those y coordinates off to the side there. I see for pi over 3, our y coordinates root 3 over 2, so we're at pi over 3. Now the last one, the sine inverse of 2, or the arc sine of 2, that is a 2. Now our range, our outputs for these, we're never going to get to 2. In the unit circle, the highest point we get to is 1. It's outside of the range, so it doesn't exist. We can't take the inverse sine of anything greater than 1 or negative 1. It has to be between that. It's outside of the range. Sine goes from negative 1 to 1 for the range. It's outside of that. All right, so now on the next page, if we're going to graph the inverse, y equals the sine of x. Now, all we do to graph this is we put our inputs into our y. So we'd have our negative pi over 2, our negative pi over 4, our negative pi over 6, 0, pi over 6, pi over 4, and pi over 3. I'm just putting those in for my y and my x values. When we're at 0, sine is 0. Pi over 6, we're at 1/2. Pi over 4, root 2 over 2, and then we have our root 3 over 2. Then at negative pi over 6, we're going to be at negative 1/2, negative root 2 over 2, negative root 3 over 2. Here's the graph of the inverse. Oh, and sorry, I forgot. Pi over 2, we're at 1, and negative pi over 2, we're at negative 1. So I'm not going to spend a whole lot of time on this. So what happens is you're just going to look like this. When you throw your values on, the inverse looks like this. Really, we're just switching those inputs and outputs. Now, the thing to keep in mind, the domain, we're going from negative 1 to 1, and the range is going from negative pi over 2 to positive pi over 2. I'm not worried about you being able to graph the inverse sine or anything like that. But just keep in mind, inverse is when you switch the x's and y's. All right, so now cosine. What we're looking at for cosine, if we graph the cosine function, here we're at pi over 2, pi, 3 pi over 2, and 2 pi. Negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. Our amplitude is 1. So with cosine, we go max, 0, min, 0, max. Max, 0, min, 0, max. So our cosine graph looks like this. Now, in order for us to be able to take the inverse, we need to restrict our domain. Here, cosine is going to be decreasing. We're going to go for our domain just from 0 to pi. So we're going to restrict ourselves in quadrant 1 and quadrant 2. Now, you can graph the inverse cosine on your own. I'm not that worried about graphing the inverse. You just switch the x and the y's. What I do want us to remember is that for cosine, we're going to be in quadrant 1 if it's positive, quadrant 2 if it's negative. Unlike cosine, where we're in quadrants 1 and 4, for cosine, we're being quadrants 1 and 2. Keep in mind, we have our pi over 6, our pi over 4, and our pi over 3. So we have our root 3 over 2, 1/2, root 2 over 2, root 2 over 2, 1/2, root 3 over 2. Now we're looking at the y coordinates. And also don't forget this one here is at 0, 1. We might need that. So the arc cosine, or the cosine inverse of root 2 over 2, it's positive, so it's in quadrant 1. And when root 2 over 2 is x, pi over 4. Now negative root 3 over 2. It's negative. It's a negative. So what we have here, we're in quadrant 2. Root 3 over 2, that's when we're at pi over 6. Now, what we need to do is we need to take pi, because we're in quadrant 2, and subtract pi over 6. So that's going to be 6 pi over 6 minus pi over 6, which is 5 pi over 6, which is our answer. A little bit more annoying for that one because we can't just throw a negative on there. To be in quadrant 2, we have to have 5 pi over 6. And now the cosine, when the cosine is 1, that's the x coordinate. We also have this one here, 1, 0, negative 1, 0. For the cosine of inverse of 1, we're going to be at 0. There's the arc cosine, or cosine inverse. Now, finally, for our inverse tangents. For our inverse tangents, once again, we already had the asymptotes as set up already for us for tangent from negative pi over 2 to positive pi over 2. And we're just looking at that. We're just going to restrict ourselves anyway from negative pi over 2 to positive pi over 2. For tangent and for arctangent, we're in quadrants 1 and quadrant 4. Quadrant 1 if it's positive, quadrant 4 if it's negative. Now I'm just going to kind of piggyback off of these. The tangent of theta from where at pi over 6, it's root 3 over 3. Pi over 4, the tangent's 1, and for pi over 3, the tangent is root 3. So the arctangent, when we're negative 1, it's negative, so we're in quadrant 4. For negative 1, it's going to be a pi over 4, so it's pi over 4. Since we're in quadrant 4, it's a negative pi over 4. Arctangent or tangent inverse of negative root 3, it's negative, so we're in quadrant 4. When tangent's root 3, it's going to be a pi over 3. To get us into quadrant 4, just throw a negative in front. And for the inverse tangent of root 3 over 3, it's positive, so we're in quadrant 1. Root 3 over 3, the tangent, that's going to be a pi over 6. Okay, so that's the key thing. Know those values from the unit circle those key points. For sine and tangent, you're looking in quadrants 1 and 4. For cosine, you're in quadrant 1 and 2. 1 if it's positive, 2 if it's negative. Thank you. I'll see you in the next video.